Hi and welcome to our first lesson recording. So today we're going to talk about Newton's laws of motion, particularly the first law of motion, which we call the law of inertia. And what is this law states about, and how do we have the law applied to our daily life situation? Although we all know that there are three laws of motion, namely, the first law of motion is the law of inertia. The second law of motion is the law of acceleration. And the third law of motion is the law of interaction. So, let's have the first law of motion, the law of inertia. In this law, it states that an object at rest stays at rest, and the object in motion stays in motion with the same speed and direction unless acted upon by an unbalanced force. In order for us to fully understand or grasp the thought or the concept of the law of inertia, let us explain every phrase in this statement. Number one, the first clause or the first statement is that an object at rest stays at rest. Right? So this means that the behavior of the object is just stationary. The object is at rest, it doesn't move, and an object is continuously not moving at all. This explains about all the objects that are staying in one position or in one location. Example, our house that was built on the ground was not moving. A statue in the park is not moving. Or even a car, which can be found only inside your garage. The second clause explains about objects that are in the state of motion. And it was said if this object are moving or in the state of motion, then they will have to move like forever with the same speed and same direction. But the condition with these two clauses is that unless acted upon by an unbalanced force, then they should change their behavior. Alright, so in order for us to fully understand the concept about the law of inertia, then we are going to use some connections. First, we have the conceptual connection wherein we're going to analyze their concepts or the parts in the way to gain information about each part as a whole. Second, we devise a plan if we can make a mathematical connection about the statement from the law or a principle in science. The third, how can we apply this law or principle in our real life situation? So let us connect the law of inertia. In our conceptual connection, this will be our question. What conditions met by the two clauses to keep on doing what they are doing or exhibit the behavior? A, presence of balanced forces acting on the object. B, is it the presence of unbalanced forces acting on the object? Or is it C, no forces acting on the object? Go ahead and think about your answer. The answer here is letter A. It is because of the presence of balanced forces that acts on the object. Since that all objects are affected by the forces that surrounds them, there are forces that are called to cancel out because these forces acts on the object as balanced force. These objects tend to keep its behavior. An object at rest will be at rest, and an object in a state of motion will be moving. if they are affected by balanced forces. Before forces acting on the object become zero, there is a presence of forces first, which makes the two clauses to do what they are doing forever. The second question is, what happened to the balanced forces when the object is acted upon by the unbalanced force? Do you have your answer now? This is the answer. When the object stays at rest and acted upon by an unbalanced force, the object will start to gain speed and will move to the direction of the greater force. On the other hand, when the object is in the state of motion and acted upon by the unbalanced force, then the object will stop or move to rest. This balance of forces cancel out each other, making use of a zero net force. But by the time that the zero net force is acted upon by the unbalanced force, that means there is another force pointing at any direction of the object, which makes the object to change its behavior. In the mathematical connection, we can also say that when these forces are balanced, therefore it creates a net force equal to zero. When the object is at rest, it has a zero velocity. That is obvious because it is not moving at all. After some time, until an unbalanced force is acted upon that object, it will just stay at rest. On the other hand, when the objects are in the state of motion, therefore, their velocity is not equal to zero. But are they changing their velocity? The answer is not. Because they are maintaining their speed and direction, or the velocity, therefore, they are not also having their acceleration, or they are not accelerating at all. So, even though that the two clauses or statements have the different values in their velocities, the resulting acceleration is equal to zero. How about the situational connection? Let us point out if we can use the law of inertia to an event or situation in our lives. Suppose that you fill the jar to the rim with water from the well and walk home a few meters to your house. The water would have a tendency to spill from the container during a specific distance. What actions made the water spill? A. The container was at rest and you attempt to move it. B. The container was in motion and you attempted to stop it. C. The container was moving in one direction and you attempted to change its direction. Go ahead and think over of which of these actions make the water spill. The answer for that is all those options are correct. Whenever you make a movement or you move a container from the rest position, then the water from inside will be changing its behavior. The water will spill. When the container is in motion, the water is also using the same speed and same direction. But whenever an unbalanced force, like you stop the motion, then some of the water inside the container will spill out because of the sudden stop, or else by changing the behavior of the container. It's also true when you change its direction. But why is it that the water has to resist these changes of the conditions? Why do water always spills whenever you have changed the conditions? The answer lies to a tendency or a property of every object to resist changes in motion. This is called inertia, the tendency of resistance an object has to change in its state of motion. When we say state of motion, it's a condition that an object behavior whose speed is not equal to zero. Whenever the object is in the state of motion, the object is moving. Whenever the object is moving or not, it will have a tendency to resist what is exhibited as a behavior. To know more about inertia, then we should be able to identify a property which we call mass. Mass is a property of matter, and it's a measurement of the quantity that an object has, which is dependent upon its inertia. Weight, on the other hand, is the force acting on the object due to gravity, and defined as the mass times the acceleration of gravity. What makes mass different from weight? Mass and weight on Earth are almost similar. Mass has a unit of kilograms. On the other hand, weight is measured in newtons. But 1 kilogram is not equal to 1 newton. Whenever a body with a certain amount of mass moves from Earth, example, on the moon, your mass will not change, but your weight will. Why? The answer is, it is because of the gravitational pull of the moon, which is different from the gravitational pull of the Earth. You see, in the moon, the gravitational pull of the moon is only 1/6 of the gravitational pull of the Earth. So you weigh less on the moon, but your mass is still the same. So what is the impact of this to inertia? An object or all objects resist changes in their state of motion, but not all objects resist these changes in the same way. Why? That is because inertia is dependent to mass. The greater or the bigger the mass of the object, the greater is its inertia. So therefore, it will be more difficult to stop a moving bus compared from a moving bicycle. It is very difficult to lift a wrecking ball weighing 1,000 pounds than carrying a small pebble on your hand. Now that you already know the difference between mass and weight and mass and inertia, let us go to a situational concept or connection about mass and inertia. Suppose that your mom and dad have two grocery carts full of load. Your mom's cart are food items and cookwares, while your dad's cart are industrial tools for making his treehouse project. If you give the carts an identical push in an effort to change their motion, which cart will have the greater resistance to the push? Is it your mom's cart or dad's? Go ahead and think over of your answer. And the answer is, the cart with the heavier load will resist more to motion if applied with two identical forces. Since mass is dependent on inertia, having a bigger mass requires greater inertia also. You wonder why these big objects or massive objects is so hard or difficult for them to move compared to the small or with less massive mass. Let us examine the second question. Suppose that there are two cars, a sedan and a fire truck, traveling at the same constant speed. Example, they're traveling at 80 miles per hour on a highway, and suddenly a tree fell and blocked the road a few meters ahead of them. Which car will exert more effort or more force to the brakes to make them stop and avoid hitting the tree? An obvious answer is the ones with a massive mass, the fire truck. The fire truck will exert more force to make its moving body to a complete stop. Since it is more massive compared to the sedan, the inertia of moving objects are still dependent on their masses. And that is, the bigger the mass of the object, the greater is its inertia. Now, before we end, I have some more challenging questions for you. If there are two objects with the same masses, the first object moves with a speed of 10 meters per second, and the second object moves at 5 meters per second. Which of the two objects has the greater inertia? All right. So chat me if you know the answer, or let's figure out the answer with our next meeting. See you and goodbye.